Hello, this is Ty and Alvin's project. Today we will be reviewing and going in depth with our first pulley system. The system is very simple, consisting of two pulleys. For our inputs, the mass of our object is 0.216 kilograms or 2.12 newtons. For physics purposes, we'll assume the strings and the pulleys are massless. Now I will let Alvin define some important terms that we have learned through this project.
Hello, here are some terms. They are important. First, what is mechanical advantage? There are two types of mechanical advantages. The actual mechanical advantage, or AMA, is the ratio of output force to input force. In other words, it is the force of the object you're trying to raise, or the load, divided by the amount of force you put in, or effort. The second mechanical advantage is ideal mechanical advantage, or IMA, which is the output distance divided by the input distance. The IMA for pulleys is equal to the number of ropes that directly support the load. In this particular system, the IMA is 2 because there are 2 ropes supporting the load, the string tied to the load and the rope on the ceiling holding the entire system up.
For example, let's take a deeper look at our system. The object is 2.12 newtons and we pull it up with a force of 1.5 newtons. Our effort is 1.5 newtons because that is how much force we use to pull. And our actual mechanical advantage is 2.12 divided by 1.5, which gives us the ratio of 1.413.
Efficiency is the output work divided by the input work. It can also be calculated by dividing the AMA with IMA and multiplying by 100 to get a percentage. In this system, the AMA, 1.413, is divided by 2, the IMA, to get 0.706, which is then divided by 100 to get 70.6%. This means that 29.4% of the energy we use to keep the system stationary is lost due to friction. If our AMA is equal to our IMA, then we will have no energy lost or 100% efficiency.
Before we made the actual project, this was our blueprint of the first system. As the mechanical advantages have already been discussed by Alvin, I will provide a basic overview of the system and why it differs from our real project. First, this blueprint was assumed to be frictionless and massless. However, our actual system had pulleys that had friction and mass. In the frictionless diagram, we would have to pull the input rope over 1.06 newtons towards the bottom right to begin moving the system, because the tension of the input rope, shown here, is half of the tension holding the mass, meaning our effort must be half of the load. On the other hand, in our actual project, which has friction, we would need over 1.5 newtons to overcome static friction.